All right. Hello, everyone. This is for lesson 12, solar energy and conductors. Lesson 11, I had you reviewed electromagnetic force, which has to do with the electrostatic force of how to basically generate a current or electrical energy. And that's just to help you review for solar energy and this lesson specifically because there's some electrostatic force that we had to talk about. So to start off, I'm going to give you the objective. We're going to explain how solar energy can be used to generate electrical energy through how it's designed and then what materials it's made out of. Before that, let me give you a brief description of how solar panels work. Solar panels are made of these photovoltaic cells, which is basically the blue or dark color squares you see on the picture. You can see down here. When the sunlight from the sun hits those cells, it causes the electrons to be removed from the front side and move towards the back. So there's an electron flow that goes towards the back. And within this back, there's usually a current. And this current is provided to transfer electrons to some electrical device to store the electrical energy. So the sunlight just basically removes the electrons from the solar cells, and then it flows through currents to go to an electrical device to store or use energy. So the materials that we need to transfer the current, we usually use semiconductors, and it's often silicon. I'll go over why we use semiconductors, but before that, let's review what conductors are and what conduction is. All right. Electrical conductivity means how well material can conduct electricity or transfer electricity through a current. So usually we use wires like we have here to transfer electricity. And anything that has a high conductivity of electricity are called conductors. So like I said, the electrical wires or any type of, most type of metals. Within your water, when people say water conducts electricity, it's actually just the metals inside the water conduct electricity. Pure water itself doesn't conduct electricity. The opposite of conductors is insulators. These have low conductivity, which means they don't transfer electricity as well. They actually usually absorb it. An example of this is usually gloves or any type of plastic. Usually when you wear gloves, you'll be protected from any like static shock. And this is, if you just look at workers working with electricity, they always wear like rubber clothing to make sure they don't get shocked and they don't transfer electricity from themselves to other people. All right, so insulators have low conductivity, conductors are high conductivity, semiconductors are in between. It's supposed to absorb some electrons and slow its motion, but also provides enough electromagnetic force to make sure the electrons move through a current. So this is just to make sure we have the electrons moving through a current, but it doesn't move too fast or too randomly. So that's why we use semiconductors. That's why for solar power panels and semiconductors, when the light hits the solar panel, the electrons break away. If we were to use normal conductors, the electrons would move randomly. We wouldn't be able to use a current to transfer it to an electrical device. But the semiconductors, even though it absorbs some of the electrons, still conducts and transfers them enough to a desired circuit so we can make sure we take the electrical energy from the electrons to where we want it. So another thing to go over is further viewing or reading. So before you do the practice assignment, I want you to choose one of the following and to read or watch. There's a description. There's a link to these two in the description and also in Schoology. The first one is just an article about how solar panels work. It goes more in depth how they work, but it's reading. The next one, which I highly recommend, is a TED talk about how solar panels work in video. So it also goes a little bit over how it works more in depth, but also about like the political aspects of like why we don't always use it, even though it might be environmentally safe or we're getting to the point where it's very efficient. So I recommend the video one, which I'll put in the, like I said, I'll put these links in the description. The practice time will just be some, I believe 3 questions of just basically reflection of what you've seen here and then what you'll read or view based on these two different resources. All right, that's all for today. Thank you.